Good morning all. I am R. Vinod Kumar, Assistant Professor, Electronics and Instrumentation Engineering Department. Today we are going to discuss about LabVIEW concepts, and specifically we are going to introduce the structures in LabVIEW. We are going to use LabVIEW 2018 version, and LabVIEW is nothing but it's a tool similar to that of MATLAB. The only difference is that it is graphical based programming language. The LabVIEW stands for Laboratory Virtual Instrument Engineers Workbench. So LabVIEW has different concepts starting from the LabVIEW environment, Boolean types, numerical data types, loops, arrays, clusters, and then the structures. So we'll just concentrate today the structures alone, and then in series of videos we'll be discussing the other concepts also. So where LabVIEW is used? So LabVIEW is mainly used in areas where measurement is done, where the acquisition is done, where the analysis is done, and also the implementation of the different processes is done, that the LabVIEW is specifically used. So in today's class we'll be discussing about the case structures and then sequence structures. So in order to open a new window, so Control N, you'll be getting these two screens, and then Control T, it will be aligned in this sequential order. So this is your front panel. So the left side will be the front panel and the right side will be your block diagram. So front panel is nothing but it will be having the controls and indicators, and the block diagram will be the wiring diagram and also the additional object related to the front panel component. Okay. So where to place this case structures? Okay, let us go to the block diagram right side. There the structures will be there. From the structures we can select the case structures. So we can drag the case structure here. So what you're going to do here is we are going to implement the 7-segment display. Okay, so let us take enum. Enum is nothing but it will be something like a selection panel where we can able to select the different numbers so that each and every number will be displayed in that particular LED thing. Okay, so right click on this enum and then edit items. If you're going to the edit items, we can able to insert the values. So starting from 0, 1. So we'll put the values up to 8. Okay, so we can able to toggle between the 0 to 8 values. So let us connect this enum to the case structure. So initially case structure will be having only true and false. So after connecting the enum, whatever we are updating in the enum will be displayed in the case structures. Now we are having 6 and 7. So where are the remaining things? Okay, so remaining things we need to add. So just select the particular case and then right click, add case after, add case after. We can able to see that all the cases, 9 cases will be updated starting from 0 to 8. Add case after and then add case after. Okay, so that's it, will be ending in. Now let us take a LED in such a way that we can able to represent that as a 7-segment in displays. Let us make a copy of this. So press Ctrl and then if you're dragging, you can make a copy of these 3 things. So this will be the horizontal model, and for the vertical thing, let us drag and place this, and then again you can place a component like this, and coming to the we are doing such a way that the arrangement is that of the number 8. Okay, now let us give the alphabets A, B, C, D, F and then G. So let us place all these components in the right side. Okay, so let us take the Boolean constant. So we are just trying to map the true and false conditions. So if it is false means it will not glow. If it is true means it will glow. So that's the concept here. So based on the cases, we will be just matching the true and false conditions. Okay, so for 0, E will alone be in false condition. So you need to touch the case and then it should be connected to the particular alphabet. Next is the number 1. B and C alone is true. All the other will go for the false condition. So from seeing the front panel, we are trying to analyze which LEDs, if it's in on condition, that particular number will be displayed. So for number 2, D and C will be in off condition. That is, D and C will be false. Go to D and then C. So others will be in true condition. Next, number 3. For number 3, D and F will be in false condition. D and F. So where is this? D and F. Next, number 4. For the number 4, A, F and G will be in false condition. A, F and G. A, F and G will be in false condition and all the other things will be in true condition. Next, number 5. For number 5, B and F will be in false condition. B and F will be in false condition. All the other things will be going for the true condition. Next, going for the 6. For the 6, A and B will be in false condition. So A and B will be false condition. For number 7, A, B and C will be true. So A, B, C will be in true condition. A, B and C will be in true condition. All the other things will be in false conditions. And finally 8. So for displaying 8, everything should be in true condition. So you can delete this false and then connect this true to all the cases. Okay, so all these connections are over. So let us press the run continuously button. So number 8 is displayed. You can able to see in the output, the front panel, 0, 1, 2, 3, 4, 5, 6, 7 and then 8. So this is the working of the 7 segment display. Here we are using the cases. So for each and every cases I can able to select that particular numerals. So this case structure application is mainly based on a larger application in industries where each and every specification requires a separate operations. So that I can able to select case 1. Case 1 operation will be a mixing section. Case 2 will be something like cutting sections, and case 3 will be something like a batch process. Or you can also consider an ATM machine. The first case will be insert the ATM card and then enter your pin and then enter the value. So it is a step-by-step process. So you can also use the case structures also, you can able to perform that particular application. Okay, so this is the first example for the case structures. Now we can go for the sequence structures. Okay, so sequence structures, let us consider the block diagram. So from the structures, let us place the flat sequence. So here we are going to consider a traffic light control program. Okay, it's a traffic light indicating program. So the 3 structures will be there. So add frame after. I'll be adding 3 frames. Okay, so we are adding 3 frames, and then we can add the numerical control so that we can able to start and stop the process. Okay, sorry, you can add the Boolean control. Now you can place the 3 LEDs. Let us increase the size of this LED. So first will be the red. Let's copy. So this will be orange, red, orange, and then this will be green. Okay, so in order to change the color of this particular, because in default will be green color, and then the off condition will be somewhat darker green color. So you need to change the colors. So right click on that particular LED, go to the properties, and there for on condition, so first is red, so let me select the red color, and I'm selecting for the off will be black color, so so that it resembles the real traffic light signal panel. So next is your orange. Let's take this orange, and off conditions will be black. And next will be green. Let us select bright green, and then off will be black. Okay, so we need to now create the local variable. So local variable is nothing but I'm going to replicate, or I'm going to create a mirror image of this, or a ghost of this red, orange and green color. I can't able to consider use 9 LEDs. Only 3 LEDs will be displayed, but the process is that when the red is in on condition, orange and green should be in off conditions. So we are going to use a NOT gate and then connect to the other two things. So we are going to create a local variable. So right click on that particular red, and then go to create local variable, place it here, and orange create local variable, and then green create local variable. Okay, so let us, so first is red is there, so red should be available here. Let us consider it here. Here only orange and green should be there. Let us place the orange here and then place the green here. The other two colors will be green here. Green is there, so red and orange. Apart from that original thing, the ghosted will be the other two colors. And now you can use a NOT gate. Right click on this and then go to Boolean and then select a NOT gate. Okay, so let us connect from here a NOT function, and here also a NOT function will be there. Let us connect to this, take a NOT gate here, and again take a NOT gate here. So we are trying to switch off the other two colors such a way that only one color remains. So another important thing is that we need to use a timing functionality so that the indicating colors will have some passing time. So say for example, if you're giving 2500 milliseconds means the red color will glow, and after 2500 milliseconds the orange, and then again the green. Otherwise we can't able to see the difference in the indicators. It will be just moving in very fast, will be in microseconds. So you can just go and create a constant, so 2500, and then again I think we can just copy this, it will be easier. So place it here. So each and every case structure should have a timing. Okay, so this is our overall case structure. Now let us press the run continuously. Okay, now we can start the Boolean. So after 2500 millisecond orange, and then after 2500 green, so it will be toggling. So based upon, let us consider that there is a traffic is there, so after 2500 milliseconds the traffic is being released, or it is considered for the next two positions. So it is one example that where the sequential operation is needed. So the operation A and then to B and then to C sequentially. So in batch process and all, this type of sequential process is very much needed. In washing machine control, everything should be in sequential order. Okay, so that's how in that particular example we can use the sequential structures, and then we can able to analyze for the different applications. So I think we'll be clear regarding the structures in LabVIEW. There are many topics available in LabVIEW, so we'll be just giving a short lectures like this. Okay, and the recap is that, so the case structures where each and every case can be selected, and then the particular operation can be performed, or I need to perform the operation in an automated manner, I can go for the sequential structure. Okay, thank you. Thanks for listening.